because I'm standing right next to it now. Well, it calibrates to the loudest voice first. I think I'm the closest, so yeah. All right, here we go. Shh. Let's begin. Shh. Shh. All right, before we start on to exercise 1C, because I covered exercise 1A, 1B, I do want to recover. It doesn't mean I've taught it once, doesn't mean you mastered it or anything. So I've got to make sure that you've learnt something. So let's recap. Exercise 1A. Name me one thing that you learnt. Can I please have names I remember? I think I had Athena. Yes? Name me one thing you remembered. What was 1A about? Notations. Yes, it was about set notation, interval notations. Good. Versus interval notations. Now, some of you might be going, oh, yes, of course. And then some of you might be like, what is he talking about? So, William, give me an example of a set notation. Element, which looks like what? Like a weird E. Fantastic. So we got element. What does the element mean, Liam?
It's part of.
Fantastic. It is a part of. You normally use this when you use like domain range, so you might say something like, so I'll do an example. You could do X is an element of, give me another set notation, can I please have Mazen? Yeah. So we've got X element of, finish this off for me. What are you going to use? Real numbers. Which, how do I do that? Ah, fantastic. What is R, which he said real numbers? What does real numbers mean? Can I please have, let's go with Xian. What are you laughing? What are real numbers? Integers, whole numbers, yes? Fantastic. Any number that you can think of, fantastic. Okay, so 0, you said positive integers like 3, half, 1.5, root 2, any number that you can think of, that's called a real number. So we've just looked at a set notation. Oh, yeah. Then what's an interval notation then? Can I please have, I forgot the names, let's go with the class list so you won't see your faces. Yeah, much better. Let's go with, what's the first name I see? I see Verity.
Yes.
Yes, Verity. Verity.
Looked at closed brackets and open brackets.
Closed brackets and open brackets. Yes, so in interval notation, we can be using closed brackets or open brackets. So give me an example of, whoops, not this one. Example of an interval notation. Can I please have, who haven't I chosen? Richie.
3 to 9, including 3 and 9.
Okay, 3 to 9, so 3 to 9, including 3 and including 9. Okay. What else could I also use? Well, actually, I'll use this one. Tell me what this means if you're going to read this. Let's do... All right. This is the one I left off for last lesson in terms of exercise 1A. What does this mean? Can I please have Trent? What means excluding? Good. So this means excluding. That is correct. But what am I saying here?
All real numbers excluding -1 to 1, except not including -1. You know what I mean?
No, I don't.
No, okay. All real numbers except just after -1 to 1.
So I'll draw it as an example what you just told me. So all real numbers except from -1 to 1. So does it look like this?
The 1 is colored in.
The 1 is colored in. Is that correct?
It's the other way around.
It's the other way around. Now, why is this? Remember, we're gonna... Fantastic. So, and this is what I mean. This is what I mean. This is a common exam question. If they chuck it in, that's what I want you to be careful of. So, try to read it like this. It means all the x values is a part of any number that you can think of except. So now that you're saying except, so except, well, except for what? Well, I want you to exclude any numbers between -1 and 1, but take 1 away as well, because you're saying exclude that. Say exclude those. Whereas here it says exclude, but don't exclude. Yes, okay, that's why. So the answer...
Bullying the cripple, you do know.
Okay, so that's what that means. Fantastic, but at least you know this is interval notation. We're using set notation, interval notation together. Okay, so that's what they are. Now, that was exercise 1A. So learning to illustrate it on a number line, learning how to describe domain range, using these symbols here. So you got your N, Z, Q. Actually, that's a good question. What was Q again? Jaja. What's Q?
Rational numbers.
Rational numbers. That still means nothing to me. What does rational numbers mean? Give me an example.
Oh, I got this. Like 1.5 and like half, maybe 1. Like not including third.
Why? What about if I gave you 1.555555 and it carries on? Is that a rational or irrational number?
Let's go with irrational.
Ooh.
Well, it has to be like the fraction, and then like A and B have to be like normal numbers.
I love the normal. Like now we know what normal is, don't we? So, can I ask, is 1/3 a rational number? But then if you type that in your calculator, it's 0.3333333, and it carries on. Is this a rational or irrational now?
Yes, tell us yes.
Yes, it is. Yes, it is. It is a rational. Recurring values, you can summarize it. So recurring values, yes, you can. Any pattern, if it's 5, 7, 5, 1, 5, 1, 5, 1, 5, 1, 5, 1, yes, you can express it as a fraction. Yes, you can. Okay? So any ones that don't, so like pi, see pi is very... Apparently, during my university years, they said that there is a finite number to it, and then it repeats its pattern. But I think that's a rumor. I'm not actually sure if that's true. They had a computer running for 20 years or something before it came up with the last value. But I think that's a rumor. 20 years, come on, really? Computer running that long? I don't know. But apparently there's a finite to it. But we now say that, we generally say it's not. We say it's irrational because the number's just too large. It's hard to write in a fraction out of that. Okay, so that's rational numbers. And Z, what was Z again? Integers. Fantastic. Excellent. So those are set notations, exercise 1A. Now let's move to exercise 1B. What was exercise 1B about? Give me, let's choose another person. Let's go with Rose. What was exercise 1B about? Relations and functions. Fantastic. Relations and functions. So tell me what a relation is. Can I please, Basil? What's a relation? It's a fantastic. It is a group of coordinates, and it doesn't matter what it is. It could be 2 coordinates, could be 1, could be many, could be none. It's a relation. Okay? We just don't know what those coordinates are. It could be x and y, it could be x, y, and z. It could be 4-dimensional. We don't know. We just know a collection of coordinates is called a relation. Okay? So collection of coordinates is a relation. An example would be something like this. I can do dots. And remember I showed you with these 5 dots, I could have an infinite amount of dots that goes like this and across those 3 and like that. Okay, so that means I've got infinite amount of dots all the way. That's just the collection of all these coordinates that cross through these 5 points. Okay, that these 5 points happen to be a part of it. But it could also be, maybe those 5 points could have been something like this. I don't know. Okay, it could be that graph too, but this is a relation. Up until you have a specific condition that you meet, then we call that relation a function. So, what makes a function a function? Give me a definition, Ben. What's a function?
A function is a relation where there is only one unique y coordinate for an x value.
Fantastic. Okay, so there's only, it doesn't have to be just one x value, it could be many x values, but you have only one unique y coordinate that's linked to, it doesn't matter whether it's many or one x value. Okay, so what I'm trying to say is, on your y-axis, when I say the coordinate, or the y-axis value 4, doesn't matter how many x values you can have. You see, I've got that x value, I've got this x value, I've got this x value, I've got this x value. It doesn't matter how many you have. you just know that you only got one y. There's no repetition of y's anywhere. Okay? An example of a repetition of y for the same x value. So let's say, I'm going to do a highlight so you can see what I mean. Wait, why isn't it coming up? There we go. This y is connected to this x. There's a relationship there. So remember I said y is always the polygamous one. It has many x's. Yeah? X is very, very, very faithful. So it's monogamous. Yeah? So this x here will not see anyone else. But as soon as this x meets another one, so let's say with another y, that x is now monogamous. Polygamous. And that way, that's not a function. Okay? So we want y is connected to x. Y can be with many x's. It can have many x's. But x doesn't have many y's. Okay? It's always asking why. Why are you cheating on me? Okay? Why are you cheating on me? Why are you doing that to me? Why are you doing that to me? Okay? So, there are x's, many x's. Yeah. Oh, have I? Everything has been skyrocketing. Not at all. Not at all. Maybe if I ever talk again, it's probably about marriage or something like that. Which is another 5 years. Ooh. Yeah. You know, this is all recorded. It's gone to the world now. Yeah.
Are we invited? Even though it hasn't happened yet?
You know, every year my year 12s always ask that, and I'm just thinking, you know what? I'm gonna bust out a lot of money just to have 1,000 kids coming to mine. Because every year I get about 200 kids, and just think about it, 200 every year. And if I'm gonna be here for 30 years, just.
Yeah, imagine just like
Oh, really? Now consider. Now it's worth it. All right, so functions, as we said, you have to have one unique y value, and you can have many x's, it doesn't matter, okay? So as long as you have one unique y value, it is a function. So examples would be like a linear function. So for every x value, it doesn't matter what the x value is, you have one corresponding y value. Hence why this is a function. Whereas a quadratic equation, actually as well as a quadratic equation, if you have one y value, it is still connected to one x. So that one x is very faithful, it's only stuck to with this one y. Hence, this is a function. When it's not a function, a square root relation. Okay? So this 1x is connected to not only the positive y value, it's also connected to a negative y value. There's 2 points. That's why this is called an inverse relation. Whereas last year what you learned was an inverse function, because we forced it to become faithful. Okay, it's a one-to-one, right? So that's what a function is. Now, there are 4 types of relations. So we know relation is a collection of coordinates. When it happens to have only one unique y value, we call it a function. But there are 4 types. 4 types of relations. Name me the 4 types. Can I please have, whom have I chosen here? Let's go, Shirley. 4 types of relations. Yeah. Wait, do we do it? Oh, did I?
Oh no, I remember one-to-one.
One-to-one? Many to one? Yeah? I mentioned about that? I'll revise it anyway. Yes, you're right.
That, right?
Did I teach that, or is it just something that you know?
you did teach it.
I did? Okay. Let's...
I mean, you teaching it.
Clearly I didn't teach it too well, so I'm going to teach it again. Here we go. One to many, and many to many. These are your 4 types of relationships, if you like to think of it that way. Year 12s. Thank you. So you got 4 types of relations. A one-to-one would just mean that for every x, there's only one x connected to one y value. The example of that was a linear equation. 1x is only connected to 1y. Okay, so that's a one-to-one. You could have another one-to-one, let's say an exponential. So an exponential graph for 1x, it's only connected to 1y. Another one that you learned that is a one-to-one is rectangular hyperbola. You see, for every x value, so 1x, you only get 1y. It's only connected to 1, so it's a one-to-one. Anyone else have another one? There's one more I can think of that you did last year. Truncus? Is Truncus one? Let's have a look.
Yeah. Yeah,
Is this a one-to-one? It is a function, but is it a one-to-one? It's a many-to-one. See, if we have a look now, with this x, it is connected to this y value, but note, this y value is also connected to another x. So the same y value, this is now many x's to one y. So this is called a many-to-one function. Okay, so this is a many-to-one function. The truncus is a many-to-one. A quadratic is a many-to-one. Okay. What is another one that is a one-to-one? Just one more that you learned last year. Yes, log graph. Actually, I didn't think of that one, but yes, log graph. Log graph is also a one-to-one. The one I was thinking of was a simple cubic graph. So if you have just like that, that's a one-to-one. Okay? So you got all these one-to-ones. Now many-to-ones, we've got a truncus, quadratic. We could also have a cubic again, but this type of cubic. Okay, that's a many-to-one. So you can see, for one y, you got many x's. Possibly even 3, actually. There you go. See? Many x's to the one y. This is a many-to-one function. So we now understand, how do you know out of the 4 types of relations, which one is a function? This is what you're looking for. 1y. So it doesn't matter out of the 4 types, you can never forget it, because you know, I said, you must have a unique y value. That's the only one with one y. These two have many y's. So these are relations. Okay, so we've got a one-to-one, got a many-to-one. These are functions. They're all relations, but this happens to be a sub-branch of it. Okay, so under relations, this is called a function. These are functions, relations as well. Okay, so now let's have a look at this. One-to-many. What's an example of a one-to-many that we did last year? Actually, we didn't do last year. No, we didn't do that. Yes, it's like it's your square root relation or the side-on parabola. Okay, because it's a square root relation. Yeah. So when you write y, when you write, there we go, y equals to root of x, that naturally should actually be, when you square root a number, it should have a plus and a minus. That's what it should have. But when we draw it as a function, we can't do that in our calculator because it only sketches functions, right? So that's why we taught you guys function. Whereas actually, in reality, when you type y equals root of x, it should have 2 answers. Every time you square root 4, 9, whatever it is, it should have a plus and a minus answer. That's the actual graph of a y equals root x. That's why when they say square root function, they ask you what is the implied domain. Because the implied domain means it has to restrict it so that this works. Okay? Or implied range. Or when it says function, you have to omit one of those. It's either top or bottom. Doesn't matter which one. Okay? You had a question, Liam?
Like why the function was 12.5 and
Oh, because I think it's just notation wise. Like when we write a 3, why isn't that a negative 3? It's only when you put a negative that's on the other side. And we can write positive 3, but we just don't. We're lazy. Or like we're always efficient. It's like saying AB, why don't we write A times B? Which we should, but we write AB. Yeah, it's the same idea. Yeah? Or even brackets, like 3 bracket 1 squared. My year 7s always get that wrong. They're like, what is that bracket? I'm like, it means times. And they're like, so you mean like this? 3 times 1 squared? I'm like, yeah. Like, oh, too hard. Like, yeah, I get it. Too many symbols, isn't it? Yeah. And if you don't put the symbol in, they're like, what do you do with a 3? I'm like, I don't know. Does it become 31? It's like, yeah, maybe. So, there you go. So you got your 4 types of relations. That was 1B. So I just went through 4 types of relations, what a relation is, what a function is, exercise, that's 1B. 1A, set notations, interval notations, how to use that to find range domain, and especially the exclusion. Okay, yep.
In a question, will they ever ask you specifically interval notation or?
No. No. So that's why, I don't know if it was you guys or maybe the other class, someone asked me, was it okay to answer, like, I gave an answer of, I did this, I did 0 to infinity, and they asked, could they use R plus union brackets 0? They're both the same. Okay, so you can use either one, and none of it would be wrong. If you used it in an exam, it's fine. Okay. All right, so that was what you did, and really the most concept that you had to take, if you really think about it, really came from 1B. 1B is the concept that you'll be using consistently because they're going to interchange between the words relation and function, and you have to know the difference between it. When you're answering multiple choice questions, you have to know what a function is in order to restrict it correctly. Yeah? And then you've got to know what a one-to-one is or many-to-one so that you choose the right answers if they ask you in a multiple choice. Yeah? Those are common ones to understand. So 1B is very important.
Many just a circle, or is there any others?
Ellipse. But really now, methods course, yeah, generally when we say many to many, the best example is a circle. Yeah, we don't do eclipse.
Yeah, what's the worst?
I'm thinking like, because an X has too many, because I'm wondering, what about this graph here? See, that has, for one Y, you have many X's. But at the same time, one X, you have many Y's. So that's a many to many.
What's mine? Wait, what's that one called again?
I don't know. I think it's actually called a hyperbola.
Yeah.
But the one that we learn in methods, we call it a rectangular hyperbola. Yeah. Yes, we did this in special.
You made fun of my graph.
Did I?
Yeah.
Does mine look better right now? Well, that's right.
What do you mean?
Mine looks damn great. Look at it. This is perfect.
So your
It's so symmetrical. All right, now let's move on to, once we've done our brainstorm, we are now going to do to 1C. Now what I want to emphasize is 1B is what I want you to learn. Okay, if you haven't really understood it, if it's still sort of fluffy in your head, you know, like if I asked you a one-to-one, how do you tell if it's a function or not, vertical line test, horizontal line test, if you have to memorize it, not good. You got to know it. Don't memorize it, because I don't memorize it, I just know it, yeah? So I want you to understand it. 1B is important. 1C you pick up easy. I can teach that very quickly. I can do it on video and you'll pick it up, right? But it's 1B. 1B you have to understand the concepts so that it follows on. If you did composite functions, it will come back to this. It all comes because you just said composite functions. See, it won't work if you don't have the word function in it. So you want to understand composite function until you get what a function is. Okay? So there we go. Let's go to 1C now, and it's hybrid functions and odd and even functions. That's about it. And I'll conclude that for today. And I'll hopefully finish a bit. Oh no, I only got 12 minutes. I wanted to finish this a bit early because I got to chase down some year 7s. They're already rebelling on like the second day or third day.
They do.
It's confidential. They're still in lockers, and I'm trying to figure out who stole which lockers.
We try to have no lockers left, like.
No, well, now a new kid needs a locker, and it's meant to be spare on my system, but it's not. It's taken by some random kid, and I thought it was another kid, so I took him out, and I found out that he doesn't have a locker because he lost it. He hasn't got a lock. So I'm like, okay, if it's not you, then who took that lock? So I went down and took a master key and opened up that lock, and I find out someone else in another house. Now I have to figure out who is in that house. Why do they have this lock? And then I found out as I was sort of walking around, I realized 2 of my students have changed their lock somewhere else. So now it's like a massive big thing, and this poor new kid is like carrying his bag. He's like, I don't know. You know, so I have to chase him and just say, here, I've given you a new lock, take it, and I'll deal with the rest. Just damn little kids. I gave them instruction 2 days ago. I said, do not swap. I'll catch you. And I am now. I'm going to catch you. Oh, I hate them. Little kids. Little year 7s. I was a very good year 7, by the way. I came in, I was like, whatever they say, I'm like, yes. I'll do it. Whatever you say, I'll do.
yes.
That sounds very funny. All right, here we go. Hybrid functions. I'm going to quickly, don't worry about that. That's meant to be our revision, but this is the one.
Oh, wait,
Get back. Yeah. No,
Go back.
back to the format.
Why got so boring?
I used to have an explosion. And this whole, I actually even edited some music when I was in EBIS. I did some music, and then it does this slow mode sort of glass shutter. And then I have like the gym background music in the back. It's like dum, 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 and then it comes out. It's like maths. No, the problem with that is when I made that for every lesson. Not only did I spend a lot of time to make those little midis and save and hard drive it, But as the kids just get excited because the slides move. And then after the slides move, they're just sitting there, they're like, I no longer want to listen. So that's why I've reduced the number of sounds, but they still carry on in some PowerPoints. But here we go. This is called a hybrid function. Nothing unfamiliar to you. We know, you know what? Screw 1C. We only got 12 minutes. I just realized I didn't teach you function notation. That's what I promised you. So that's what I'm going to fix in 1B. 1C, when you guys come, I'll do it in the video so you can watch over the weekend, and I'll cover 1C. 1C and 1D will be easy. It's when we get to composite functions, they'll be tricky, yeah? But for now, 1B, that's your homework. That's what I want you to do, yeah? But let's go back to, yeah. Or like I said in the discussion page, I wrote, whoops. Oh, what happened to my, where's the blank one? There we go. In the discussion page, someone, not from this class, from the other class, put in, said, do they have to do all the questions? And I answered in that discussion. I said, no. I put up it as a guideline. So if you want to do all, fantastic, great, that's on you. But remember, you got methods, you got other subjects that you do as well, and you only got a number of months up until November before your exams. You got to study smart, okay? Because I give you all these questions doesn't mean you sit there and go, oh my God, I got to finish 20 questions by tonight. Don't. You see, the aim is whatever I just did with you, summarizing. The reason why I do that is because I want to know, have you learnt the concepts? If you learnt the concepts, you can pick out a few questions. Do 1, 2, try out the medium hard ones, jump to the last one. If you could do the last one, move on. Why do you have to do all questions? You know, like pick the ones that you think are hard. Don't do the easy ones, go, yeah, I get it. You know, don't. Do the hard ones like gym. You don't walk in and pick up 2 kilo weights and you're like, yeah, I'm gonna get big. No, if you wanna get big, you're gonna have to push yourself. You're gonna have to do something that you can't lift. That you're like, oh, it's too hard. And the next day you come back in and try it again. That's the same thing with maths. You wanna train that mathematical mind of yours, you don't do easy ones, you try to extend yourself by doing challenging ones and you keep coming back for more, yeah? I don't lift.
What do you mean?
I box. This comes from boxing, man. Just keep punching. Which I haven't sparred in a while, that's sad. My neck still hurts since that fall.
Really?
Yeah, I'm seeing an osteo this Friday, so hopefully we'll get something on about that. Anyways. Last part before, I've only got 7 minutes before I chase down those kids. So, function notation, write down this is your notes for today to finish off 1B. Just the last part of 1B. They'll ask you to write things in what we call function, take away the S, notation. Okay? Function notation, what is function notation? I'll give you an example of something you've seen so far, if you've been doing your homework. You'll see something like this. X, Y, colon, I don't know, let's do Y equals to X squared plus 2, comma, let's do X element of 0 to 4. Yeah? I say that's something that you've seen, yeah? A function, this is not function notation by the way, okay? Your job, when do you use function notation? Use it anytime they ask you to state a rule, state an equation, find the equation, find the rule, especially if it's 2 marks. 2 marks because they want you to write it with the domain and the correct equation. So normally this happens when they say find the inverse function, state the inverse function. So the first step is you have to rearrange this, swap the x and y's, find the inverse function, and then you got to state the correct domain. Yeah, and there's a format to it, and we use what we call function notation. Now this is how it looks. It looks like this. I'll give you an example of what it looks like. Okay, so if I were to write this as a function notation, I can use f. It could be g, it could be h, it could be t, it doesn't matter what it is. It's just representing what this function is. So I'm calling this f for now. F, and because I'm going to talk about x's, that's why it's going to have f of x. Now here, what goes here is your domain. Your domain is currently x is an element of 0 to 4, whoops, open bracket. Okay, now this is where most of you don't know what this is. This means maps onto, which I'll explain what maps onto is. And R we know means all real numbers, right? Then you write f of x, well, what is the function? The function is x squared plus 2. So this is not something that you're unfamiliar with. What you're unfamiliar with is what this whole thing means. So what this means here is you've got a function where we labeled it f, so I got f here. When you write f of x, it just means, well, the equation is in terms of x. I mean, it could have been f of t. And that just means that this would be t squared plus 2. That's all. Okay, so it depends on what this second variable is. Your x-axis variable is here. F just tells you what letter you're using. I could use g, and then that'll be g. Okay, so this is your function notation. This is your domain. So I'm going to write here, domain. What is this arrow maps onto R mean? We call this your codomain. Okay. Now your codomain, it's always going to be R in methods, only because we're dealing with only numbers. What this actually means is when you take a domain, well, they want to ask, like, what are you taking this from? Where are you taking it away from? Because when you get to university, you'll be doing complex numbers, i's and whatnot, and they're not under the real number system. So they might change that to Z, or they might change it to C for complex. But in our case, because in methods, we're only dealing with real numbers, we don't learn complex, we only use R. So what this really means, the codomain just means, what are you working with? So this domain 0 to 4, where is that coming from? What is it? What is it representing? It's coming from R. So there's a plane, they call it like a plane, like a massive list of numbers, and it's like this massive plane, and we're taking a sample out of it. That's what it means. So that's why they say maps onto R. So you've got this plane, and it maps onto that. Okay, that's what that domain is. So in a way, what I'm trying to say is you're always going to write arrow R. But just in case you didn't know what it means, that's what it is. Okay? But that's how you write it. And so some of the questions will give you something like this, and they expect you to write this as a function notation. Okay? I'll do another one as an example so you can see. Let's say I give you, let's do y equals to, actually, let's do, anyone who does physics here?
I used to.
Okay, what was the, I remember S equals to UT, something like that.
U plus AT.
U plus AT. Oh, this is bad. But let's do this anyway. Okay, let's say the x-axis is T. Okay, x-axis is T. Is it VT? Ah, who cares? I'm gonna do this now. I don't care. I'm making it up. I'm making it up now. Okay? Let's say, and I'm going to use numbers now so that I don't confuse you. Let's do 3, 9. Cool? Is that easier? I just made it up. Here we go. We've got an equation. We've got a function. S is the subject. Okay? This is your terms. It's what it's made of. So, in terms of the y-axis, S is your y-axis. T is your x-axis. So if I were to write this, I would write something like this. As a function notation, I would use S. That looks like a quadratic equation, so maybe the domain is R unless I restrict it. So domain is R, maps onto R, comma. Because I'm dealing with S and it has in terms of T, I would now say S of T equals to 3T plus 9T squared. Does that make sense what I'm doing? Yeah, so I'm just changing an equation that you know, but what's the benefit of this is you get two things. The domain and the function. And in the function, it tells you what your x variable and y variables are. Okay, that's why we call this a function notation. Okay, and that is the expectation when you write your answers in your SACs or exams. That's what I want to see. And I say that every single year, and I still catch out at least 5 kids who don't do what I just said. Okay, and it will say in the question, it will say state the rule, find the rule, and it's 2 marks. 2 marks means domain and an answer. Okay, so you've got to get that right. So when you see 2 marks, don't just give me that, because a lot of times it's easy to get that when you do composite functions. What you're missing out on is the domain. Okay, so keep that in mind. The domain matters. All right, and that concludes for today. Yes, I met in 7 minutes, and we're gonna do about 2 minutes before I'll let you guys go early. And I'm running over there and catch that kid. Catch him. I'm gonna find them. Yeah, I'll be safe. I'm gonna tell them. I'm coordinating Coleman.